Hi everybody, I wanted to do an oblique example for graphing rational functions. So here we have r of x equals x squared plus 3x plus 2 all divided by x. So the reason why I know I have an oblique example is that the degree of the numerator is 1 more than the degree of the denominator. To begin, let's start by factoring our numerator. It's going to factor to x plus 2, x plus 1, all divided by x. And so it can't be simplified, and so the domain is going to be all real numbers without the number 0. This is another way that we can abbreviate the domain. This slash is referring to without. So you're saying all the numbers except the number 0. So this often works well when there's like 1 or 2 numbers you're excluding. Let's go ahead and find our intercepts. So to find the x-intercept, you need to set r of x equal to 0, which really means we need to set x squared plus 3x plus 2 equal to 0. And we did that, and since we factored it, we know that the x-intercepts are going to be x equals -2 and -1. And there's not going to be any y-intercepts because we're supposed to find r of 0, and that was the number that we threw out. Okay, so now we want to find the vertical asymptotes. I like to abbreviate it VA. And so the vertical asymptote will be x equals 0. And this also has multiplicity 1, which means that the function is going to be approaching opposite infinity near x equals 0. We already know that there's no horizontal asymptote, but we'll still have that slant asymptote. And in other problems, you may have to do polynomial long division or synthetic division. Since we have a monomial in the denominator, I can divide each term on top by x. So I'm going to have r of x equals x plus 3 plus 2 over x. And so the idea of horizontal asymptotes and slant or oblique asymptotes is that we want to know what's happening as x gets really, really, really large. And so we can write that using that arrow notation or the end behavior notation we saw earlier. And so as x goes to infinity, this function r of x is just going to approach x plus 3, because as x is getting larger and larger, 2 over a larger and larger number is tending to 0. So we're saying that r of x is going to approach x plus 3. So that slant asymptote is y equals x plus 3. Now, what we also need to do is still check to see if the curve crosses the slant asymptote. So we need to solve, let's just put cross, will it cross? So will x plus 3 equal our x squared plus 3x plus 2 over x. To solve this rational equation, I can multiply both sides by x, and I'll end up with x squared plus 3x equaling x squared plus 3x plus 2. And this is not there's no way we can solve for x. This x squared plus 3x is not the same as x squared plus 3x plus 2. So we can say it does not cross. So now I just went to a new page. Now we want to go to the number line, plot our x-intercepts in our vertical asymptotes. So, and we want to make it sure it's in increasing order. So -2, -1, and 0. And then this is where we're testing to see if the curve is above or below. And so this is also where like multiplicity can come into play, because since the numerator, each factor in the numerator has degree 1, the multiplicity 1, we know that the curve is crossing through -2 and -1. We just need to determine, is it coming like from above and then below, or the opposite way. And to do that, we can choose points in between each of these intervals. So say we pick -5, -1.5, and -0.5, and 5. And so we'll plug this into R of x, and also finding more points for our curve. So we have R of -5 turns out to be -2.4, R of -1.5 turns out to be, and these are all approximates, 0.167, R of -0.5 is equal to -1.5, and finally R of 5 is equal to 8.4. So what that's telling us is that to the left of -2, it's below, and between -2 and -1, it's above. The curve's above. Between -1 and 0, the curve is below. And greater than 0, the curve is above. So what that's telling us is that it's going to come through like this, and then come back through like this, and then this is where our vertical asymptote is. Alright, so let's go to our next page, because now we have all the pieces to graph it. Here's my graph. We have our vertical asymptote was at x equals 0. Let's see if I can like change the color, or so don't, oh, it's in the line mode. That's going to be helpful too. Boop, 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 boop. Boop, 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 boop. Boop, boop, boop. So it's, sorry, it's a little crooked, but there's the vertical asymptote. And let's also graph our oblique asymptote. It was x plus 3, y equals x plus 3. So I can go ahead and maybe here's 1, 2, 3, and then here's the y-intercept. Here's the y-intercept. So then it has a slope of 1, so up 1, over 1, and then up 1, over 1. It looks like that's not filled in. And so let's just kind of imagine that this is y equals x plus 3. This would happen at -3. Okay, and then we can plot our x-intercepts. And so we can -2 and -1, so those are points here, and that was it. And so now we can rely on our points that we found. So there was -4, -5, and it was about -2.4. And so since we know it's below, so then this is 1, 3, so about right here, negative 2.4 is there. And another point was negative 1.5, 0.167, so right around here. Negative 0.5, negative 1.5, so around there. And then 5 and 8.4. 3, 4, 5. And then if we play with a oblique asymptote some more, we're going to see that 8.4 is going to sit above this. So maybe right around here. And so it could be a little confusing at this point, like, okay, what's happening at negative 2? What's happening, what's happening at 2? What's happening at 1? But since we know that the x equals 0 has multiplicity 1, that on one side it has to be coming from it has to be coming from opposite infinities. So what that's telling me is that my curve's probably doing something like this, not really curling up towards the vertical asymptote, and then on this side, oh, that's terrible. Ugh. Okay, and so this is my curve. So one of the tricky parts in doing this is just putting all the pieces together. So I like to play with my multiplicity and find those points to determine if the curve is above or below the x-axis. Hope you found this helpful.